Okay, so this was yesterday's homework. I do want to take up number 9 really quickly because it is a very interesting question. Alright, a circle with radius 32 is cut into 8 equal parts as shown in the diagram. Calculate the perimeter of each part given your answer correct to the nearest milliliter. So a millimeter. So what you're trying to do is you're trying to figure out the perimeter of that, the highlighted part. This side I know is 32. This side I know is 32. So what I need now is I just need this arc right here. Perimeter of a circle, what do we call it again? The fancy name? Yep. Circumference. What's the formula for circumference of a circle? Yeah, you are absolutely correct. So pi times d, which is 3.14 times your diameter. In this case, if radius is 32, diameter is 64. It's double it. All right. There is a second formula that's 2 pi r. It doesn't matter which one you use. Let's just say I use that. And then 3.14 times 64. 3.14 times 64. I get 200.96. Okay, this is the circumference of the whole circle. Do I want the whole circle? No. How much of it do I want? Right, I only want 1/8 of it. I only want this part. So divide that by 8. So the arc part only, divided by 8 is 25.1. 25.1. Is that my final answer? No. That's centimeters. Okay. 2 things. Yeah, Martin. Right. So I want the highlighted part. I want to know the perimeter of one section. So I have to add the 32 to get the highlighted part, which equals 32 plus 32 equals 89.1. What's my unit here? Yep. Oh, careful. What is the 32? 32 centimeter. That's right. Okay. As Sarah pointed out, that's not what I want. I want in millimeters. So you have to do the conversion. See, that's why I chose this question to go over with you guys. What's the connection again between centimeters and millimeter? What's the conversion rate? Times 10, right. So you have to times it by 10 to go from centimeter to millimeter. And so it's 891 millimeter. That's your final answer. Millimeter. Okay. How many of you got that? Okay. How many lost half a mark somewhere? Okay, good. Okay. So let's move on to today's where we do volume and surface area. Okay. It's easy. Do you know why it's easy? Why is volume and surface area easy? Martin. Alright, but and the second one and the third one, they're basically just multiplying stuff. But how do I know what I'm multiplying? Based on what? Formula, right? And do you have to memorize any of these formulas? No, because you are given the formulas. Ta-da! And you're given the diagram too. Okay, so you can't say I don't know what those shapes are, because you can match it up. Okay, so the first one right here, this one, what do you call this shape? What is this one called? Grace? Rectangular prism. Excellent. So rectangular prism, and I'm looking for volume and surface area. Okay, so I have to use both of these equations. Now notice there's a whole bunch of gibberish right here. Okay, what you want is just the last sentence, basically. The last one. All the ones before is just telling you how they came up with the formula. Okay, so you're just looking at that last one. For example, this right here. Which one do you guys like more? Base times length times height divided by 2, or half base times length times height? Who likes this one more? Who likes the second one more? Okay, yeah, so I like this one more as well. So just highlight that one, the one that you like more. All right, same thing here. Highlight this one, the one that you like more. Okay, see here, like it's just length times width times height. So what is this A base times height? This is just telling you how they came up with the formula. Okay, so highlight the last of it. So let's do that now. Okay, so volume is length times width times height. Okay. How I would suggest doing these questions is write a letter right beside that number. So length is 18, width is 4, height is 5. So when you substitute it in, just like when we did with the slope formula, you don't get mixed up. So 18 times 4 times 5. Somebody who's good at mental math. Not me, so I took out my calculator. And what do you get, Ethan? 360. Good. Yes. And see how that's why it's easy, because you can use your calculator and I give you the formula. So nothing to worry about. Say that again. You're thinking about a circle and angles. So like that's the next chapter. Okay. For volume, what's my unit? Catherine? To the 3 cube, yes. But is it centimeter? It's meters, that's right. So meters cube. Okay. Volume, 3D shape, that's why it's a 3. Okay. Then, am I done this whole question then? No. If this question was out of 4, you would have only got 2 out of 4 because I left the second half of the question blank. Second half of the question, surface area. So surface area, look at the formula sheet. Someone read me the formula. Audrey, can you tell me the formula for surface area of a rectangular prism? Yep. Right. Okay, so make sure you read the right formula. If you don't choose the right formula, then the math will be wrong. Simple as that. SA just stands for surface area. Now here's a quick question. Is there a difference between area and surface area? Who says yes, there is a difference? Who says no? No difference. Okay, I saw 3 people in my class. Let me ask that again. Area, surface area. Okay, no difference. Put up your hand. Area, surface area. Okay, yes, difference. Okay, what's the difference then? Area, just like the 2D shape, so it's like the top of like the rectangle, that's just like a 2D shape, like the area. Surface area is like the like 3D shape. Right, so the only difference is 2D versus 3D. Okay, so if it's like, for example, I want to find the area of the tabletop, that would be just area. But can I also say find the surface area of my tabletop? Yes. Okay, so technically it's the same. It's just whether you're talking about a 2D shape or 3D shape. But remember, area is area.
Do we have to start with the formula every single time we start?
Yes. Good question. I do want you guys to copy out the formula as the first step, because if something is wrong in the whole thing and then I can see that, oh, the mistake that you made was because you chose the wrong formula. Okay. And it also helps with substitution. So 18 times 4 plus 4 times 5 plus 18 times 5. Okay. Good old calculator. With this, you can punch everything in too. Bracket. And then put exactly as you see. So you don't even have to do it by steps. Alright? If you see a bracket, make sure you have that bracket. And you get 364. What's my unit here? Zoe, what's my unit for surface area? I don't see cm here. So first off, it's in meters, but surface area is meter what? Area. 2, right? Meter square. Okay, 2-dimensional. So 2. On the test, if you get your unit wrong, will you lose marks? Yes, half a mark off every time. Okay. What is this one called? What is this shape called? Grace, what is this called?
A cylinder.
Cylinder. Good. Okay, so cylinder. Oh, Dina is not here today. I just realized. Eliana, can you tell me the formula for cylinder? Volume? Pi r square h. Okay. Pi 3.14, radius 4 square, height is 6. Okay, nice and easy plugging the numbers in. So 3.14 times 4 times 4 times 6. Okay, on the calculator, that's all I did. I get 301.44. Again, what's my unit? Melissa, what's my unit? Perfect. Okay. Pi r square. What is pi r square? Area of a circle. So if you think about it, pi r square is the area of this circle. And then when you times it by the height of it, that will give you the volume of the whole shape. Okay, so pi r square, this part, first part of the formula is just the face, the top. Surface area of a cylinder. Hey, Eliza, can you tell me the formula for surface area of a cylinder, please? Perfect. Okay. 2 pi r square, where did this come from? What's 2 pi r square? Yep.
The total area of like both of the circles.
Right, the top and the bottom of your cylinder. And so that means that 2 pi RH is this lateral part in the middle. Okay. Remember, surface area is like you unfolding a 3D shape and then adding all the surfaces together. So 2 times 3.14 times radius, which is 4 square, plus 2 times 3.14 times 4 times 6. Okay. Again, put everything into your calculator. Just be mindful of the brackets. 4 square, right, plus 2 times 3.14 times 4 times 6. So I'm putting as I see it, exactly as I see it. Press equal, I get 251.2. My unit. Martin, what's my unit? cm squared. Okay, now your question?
area going around 2 pi r, bracket on the space.
Oh, you could. Both works. So yours is the factored version. This is the expanded version. Okay. So far, are these two examples easy? All right. Does it seem too easy for grade 9? Okay, so how can I make this? Well, you guys seen these questions. You've seen this in grade 7 and 8. So how can I make this a grade 9 question? So suppose instead of saying something like this, I can say how much space is inside this shoebox? Okay. Yeah. So, but then you have to come up with a diagram, and you'll have to know that I'm referring to a rectangular prism. How much wrapping paper is it gonna take to wrap up this shoebox? Okay. Then you need to know wrapping paper on the outside, which means surface area. All right. An example of this one is how much Campbell's soup is inside this can. How much Campbell's soup can this fit? Okay. So then you'll need to know it's a cylinder that we're talking about. What about surface area? How can I rephrase my question into a word problem for a can? Wrapping paper? Merry Christmas. Here's a can of corn for you. I wrapped it myself. The paper, the label? But then the label, right? The label doesn't include the top and bottom. What is your...
How much metal does a can take to use?
Right. How much metal or aluminum is used to make the can? Okay, that will be an example of surface area.
Can has edges, right?
No, no. Okay. Now, for example, I like the label idea, but let's say I just want to put a label on a normal actual can of Campbell's soup. What's the surface area of that label? What's the formula that I would use for that label? Here's the $1 million question. Okay, so for my label, my can label, yeah.
You could calculate the whole thing and then and calculate the straight like the top and bottom separately, and then there's the subtraction.
Okay, I like your idea. So Adrina said calculate everything using this whole formula and then subtract the top and bottom circle. Okay, that would work, but that's actually extra work. There's an easier way. Ethan. Right. So if you take a look at this formula and break it down, this is the top circle, this is the bottom circle, and then this is the lateral surface, which is the middle, and which is just the label itself. So if that's the case, if I only want the labels area, then I would take out this part of the formula. Okay. Now let's say I'm being so difficult and I say that I'm putting an expiry date label on the bottom, but not on the top. So how would my formula change? Right. So if I only want one of the circle, then my formula would change to pi r squared plus 2 pi r h. Good. Okay, so you're given the formula for the whole thing, but I could make it hard and say I only want part of this cylinder. I want some of the cylinder. I want to add on this cylinder. Later on in the thing, you'll see in the homework, you'll have a cylinder sitting on top of a prism. Okay. Last one. Let's go over this last one first. Possibly. Okay, what is this shape called? Grace, you've been so good with your shapes. Triangular base prism. Perfect. What's the difference between prism and pyramid? People always mix those two up. Yeah. Longer? No, not longer. Yep. Okay. Okay. Not for. Uh, um, Catherine? It doesn't have to be a square. It could be triangular base. It could be rectangular base. Alright. What's the difference between pyramid and prism? Pyramid, prism. Okay. Let's hear it. No, it doesn't have to be. It could be a rectangular base prism, pyramid. Yep.
It has one additional vertex compared to its base.
Right. Okay, vertice. So a pyramid, everything goes to one vertice, whereas a prism is like a Toblerone chocolate bar. Okay, so you have an edge. You have an edge versus a vertice. Alright, don't mix up those two. A lot of people mix up those. Alright, so for this one right here, so now that we know this is called a triangular base prism, volume. Let's do volume first. Volume is base times length times height divided by 2. Okay. Looking at this diagram, what's my base? What's my length? What's my height? Which number is my base? Hayden? 8. Which one is my length? 10. And which one is the height? 6. Okay. Whenever you do, actually no, it's gonna mess up this right here. Okay, I'll do something else instead of that. Okay, so Grace, what did you call this shape again? Yeah. Triangular base. So your base is a triangle, right? So that's why my base and the height is based on this triangle. Just like what we were talking about with this cylinder right here. My base was a circle and then I times the height. My base is a triangle and I'm timesing the length to give me my volume. So 8 times length times height divided by 2. So 8 times 10 times 6 divided by 2, I get 240 unit centimeter cube. Okay, this is the easy part. Nice and easy. Done. Surface area. This is the tough part. Alright. Out of this whole page of formula, this is the one formula that I don't like. It's very confusing. And if you take a look at the diagram right here, they actually use this as length for the triangle. And then this as the actual height of the thing, which is not nice. Okay, and then they use A and B for the two other sides. So for this one, just this one, I don't like it. What I would just do is I would draw a net for this. All right. What's a net? Anyone know what's a net? Yeah. Yeah, unfold the parts. So unfolding this shape right here, how many rectangles will you see when I unfold this? 3 rectangles. So 1, 2, 3. And then what's on the top and bottom? Triangle. Yeah, 2 triangles. Okay. Right, now to put in the numbers. So this is 10 right here. All the sides are 10. This side right here is 8. Okay. Okay. Do I know So this side right here, is this side right here. Okay, do I know how long is that side? Is that given? No. Okay, but based on what we learned in the last 2 days, what do you think we have to do? Pythagorean theorem. But what shape do I have to use Pythagorean theorem on? Right triangle. Is this a right angle triangle? No. Can I make a right angle triangle out of this? Yeah. How? Excellent. Good job. You guys are awesome. You guys are so smart. Hey, when I cut it in half, it's not the best drawing, but we'll say it's an equilateral triangle, and you're cutting it down the middle. So how long is this side? This side is 6. How long is this side right here? 4. Okay, so be very careful with whenever you do this type of questions, it's always half the base. So this is 4, not 8. This is like the number one mistake people do with these questions. Right? So this is c squared equals a squared plus b squared. That's what we did yesterday. So c equals 6 squared plus 4 squared, as we said. So 6 times 6 plus 4 times 4, square root that, square root the 52. You get 7.2. Okay, so this is 7.2 right here. And this here is 6. Okay. Do I have all the numbers that I need? Yeah. And all the questions that you see will be like this. Like it will be symmetrical. Same on both sides. Okay. So this side is the same as this side. So now we have all the information. We can add up all the areas. Area of the two triangles. What's the formula for triangles? Yep. Base times height divided by 2. Good. And how many triangles do I have? 2. Yeah. So 2 times base times height divided by 2. The 2's are gone. So I'm just left with base times height, basically. Okay. And then I have this rectangle plus this rectangle plus this rectangle. So I have 2 times length times width. Those 2. And then I have one more length times width, or I'll say base times height for this middle rectangle. Okay. So for the triangle, I have 8 times 6. For the 2 rectangle, I have 10 times 7.2. And then finally, for the middle section right here, what's the dimensions of this middle section? This part right here. Oops. That part? Yep. 10 by 8, right? Because this is 10, that means this is 10. So 10 by 8. Okay, so plus 10 by 8. Okay, put everything into the calculator. So now that the formula is simplified, it doesn't look too bad. Yeah, I'm gonna go to that in a second. Let me just finish up this. Say that again. All the ones that I'll give you, I'll make it isosceles. Yeah. Huh?
Should we write that formula instead?
So, oh yeah. So you were asking, isn't this kind of like the same formula as the other one right here? Kind of. Okay. But why this is misleading is because you have to always refer back to the diagram to know which one they use. So what's A? What's H? What's L? What's B? If you make one of those mistakes, your whole answer is going to be wrong. So this is a little longer, but there will be questions where you'll have to know how to draw a net anyway. So this is good to know. Okay. I would say out of the whole thing, the hardest shape is the triangular prism. And this is as hard as we'll get because you have to combine Pythagorean theorem with a net drawing of a 3D shape and then calculate the surface area. But if you are okay with this, then yay, you can have the test tomorrow. Shaya?
Draw like the net drawing.
There will be questions where I ask you to draw the net for marks. So if I don't say if I don't assign marks for the net or if I don't ask for a net, then you don't have to draw it. Yeah, but there will be questions where draw part A, draw the net. Part B, find the surface area, something like that. Yeah.
So what is formula we posted on the chart in the test?
So you'll get exactly this sheet right here, but it's just that I don't like this formula because the letters don't make sense to me. If it makes sense to you, you can just use this.
It's probably because I'm not doing A's.
Yeah. So this one, I think it's more understandable. Okay. Yeah, so that's the lesson. That's a 30-minute lesson. You can try these ones right here on page 17 and 18. And then notice this one. What shapes do you see here? What shapes do you see? Right, okay, so it's a composite 3D figure. So what you probably have to do is when you calculate the surface area, you won't calculate those circles, for example. Okay? So try these ones, page 17 and 18. And yeah, we'll take up some of these tomorrow.